What's up, guys? My name is Mohammed Jawad, and I want to talk about the VLAN and VTP. A VLAN is a logical broadcast domain that can span multiple physical LAN segments. Within the switch interwork, VLANs provide segmentation and organizational flexibility. A VLAN can exist on a single switch or span multiple switches. VLANs can include hosts and endpoints uh, in a single building or multiple building infrastructures. We can have a lot of VLANs like sales, human resource, and engineering, or few different VLANs spread across all few floors. Cisco switches implement VLANs by only forwarding traffic to destination ports that are in the same VLAN as the organization. Each VLAN on the switch implements address learning, forwarding, and filtering decisions and loop avoidance mechanisms. Just as thought, the VLANs were separate physical switch. Ports in the same VLAN share broadcast. So ports in different VLANs do not share broadcast, as illustrated in the figure, where a PC3 and PC4 cannot ping because they are in different VLANs, whereas PC1 and PC2 can ping each other because they are part of the same VLANs. We have a VLAN segmentation, which means a large flat network generally consists of many end devices or endpoints, no matter, in which broadcast and unknown unicast packets are flooded on the all ports in the networks. One advantage of using VLANs in the capability to segment the VLANs on a layer 2 broadcast domain. All devices in VLAN are members of the same broadcast domains. If an endpoint device transmits a layer 2 broadcast, all other members of the VLAN receive the broadcast. Switches filter the broadcast from all the ports or devices that are not part of the same VLANs. End-to-end VLANs, which means the term end-to-end VLANs refer to a single VLAN that is associated with a switch port widely dispersed throughout an enterprise network on multiple switches. A layer 2 switches campus network carry traffic for this VLAN throughout the network, as shown in the figure, where VLANs 1 and 2 and 3 are spread across 3 switches. Local VLANs means the campus enterprise architect is based on the local network and local VLAN model. In a local VLAN, all users of a set of geographically common switches are grouped in a single VLAN, regardless of the organizational function of those users. Local VLANs are generally confirm the wiring closed, as shown in the figure. In the other words, these VLANs are local to a single access switch and connect via a trunk to an upstream distribution switch. If user move from one location to another in the campus, their connection changes to the new VLAN at the new physical location. As you see in the figure, in the local VLAN model, layer 3 switching is implemented at the access level, and routing implemented at the distribution and core level. Also, as shown in the figure, to enable users to maintain access to the resources they need. An alternative design is to extend routing to the access layer and links between the access switches and distribution switches are routed links. Let's talk about implementing a trunk in a campus environment and realize what is the trunk. A trunk is a point-to-point link that carries the traffic for multiple VLANs across a single physical link between two switches or any two devices. Trunking is used to extend layer 2 operation across an entire network, such as end-to-end VLANs, and as you see in the figure, PC1 in a VLAN 1 can communicate with the host in a VLAN 1 on another switches over the single trunk link. The same as a host in a VLAN 20 can communicate with a host in another switches in a VLAN 20. It is something obvious. As we discussed earlier in this subject, we can allow a switch port that connects the two switches to carry more than one VLAN. It must be configured as a trunk. If frames from a single VLAN receive a trunk link, a trunking protocol must mark in the frame to identify its associated VLAN as the frame is placed onto the trunk link. To receiving switch then knows the frame's VLAN origin and can process the frames coordinationally. On the receiving switch, the VLAN ID, VID actually, is removed when the frame is forwarded onto the access link associated with its VLAN. And a special protocol is used to carry multiple VLANs over a single link between two devices. There are two trunking technologies: inter-switch link or ISL, that is Cisco trunking encapsulations, and IEE or IEEE 820.1q for industrial standard trunking methods. When configuration and 820.1q trunk, a matching native VLAN must be defined on each end of the trunk link. A trunk link is inherently associated with a tagging each frame with a VID. The purpose of the native VLAN is to enable frames that are not tagging with a VID to receive the trunk link. Actually, because the ISL protocol is almost old, we just focus only on 802.1q. We want to talk about how ISL encapsulation actually works. Currently, all switches support 820.1q tagging for multiplexing traffic from multiple VLANs on to a single physical links. As you see in the figure, we have a ISL frame. IEEE 820.1q trunk links employ the tagging mechanism to carry frames for multiple VLANs, in which each frame is tagging to identify the VLANs to which the frame belongs. As you see in the picture layout of we have a layout of 802.1q frames. Here we have original frames, and here we have 802.1q tagging frames. Now we want to talk about What is a native VLAN in 802.1q trunking? Well, the IEEE 802.1q protocol allows operation between equipment from different vendors. All frames except native VLAN are equipped with a tag when traveling the link. As you see in the picture, we have a native VLANs in 802.1q. A frequent configuration error is to have different VLANs. Is to have a different native VLANs. The native VLAN that is configured on each end of an 802.1q trunk must be the same. It is so obvious, and is configured for native VLAN 1 and the other for native VLAN, for example 2, and frame that is sent in the VLAN 1 on the one side will be received on the VLAN 2. VLAN 1 and VLAN 2 have been segmented and merged. There is no reason this should be required, and connectivity issues will occur in the network. If there is a native VLAN mismatch on either side of an 802.1q link, layer 2 loops may occur because VLAN STP BPDUs are sent to the IEEE STP MAC address. Actually, we have a specific MAC address for untag. Cisco switches use Cisco Discovery Protocol (CDP) to warn on a native VLAN mismatch. Unselected version of Cisco iOS software, CDP may not be transmit or will be automatically turned off if VLAN 1 is disabled or on trunking. By default, the native VLAN will be a VLAN 1. For the purpose of security, the native VLAN on a trunk should be set in a specific VID that is not used for normal operation elsewhere on the network. We use a switch configure, enable configure terminal, and type switch port trunk native VLAN, and we choose another VLAN ID for native VLAN. And if we want to talk about DTP, and if you like to know what is the DTP, it is a protocol called Dynamic Trunking Protocol. On a trunk port to negotiate the trunk state. DTP negotiates the operational mode of directly connected switch port to the trunk port and select an appropriate trunking protocol. Negotiating a trunk is a recommended practice in multiplayer switches network because it avoids network issues resulting for trunking misconfigurations for initial configuration. But best practice is when the network is stable. Now we want to talk about trunking modes and methods. We have several types of method in trunking, and the first method is access. It works to the interface permanent non-trunking mode and negotiates to convert the link into a non-trunk links. The interface becomes a non-trunk interface even if the neighboring interface does not agree to change. Another trunking mode is a trunk. When we put in the interface into the permanent trunking mode and negotiates to convert the link into a trunk links, the interface becomes a trunk interface even if the neighboring interface does not agree to change. Another trunk mode is negotiate. prevents actually it is prevents to interface from generate DTP frames, which means you must configure the local and neighboring interface manually as a trunk interface to establish a trunk link. Use this method when connections to a device or connecting to a device that does not support DTP. Well, we use it for server mode actually. Dynamic desirable makes the interface activity attempt to convert the link to a trunk link, which means the interface becomes a trunk interface if the neighboring interface is set to a trunk, desirable or auto mode. Dynamic auto. This is the interface willing to convert the link to a trunk link. It means the interface becomes a trunk interface if the neighboring interface is set to trunk or desirable mode. This is the default mode for all interface in a Cisco iOS. You should consider we have a VLAN ranges. ISL supports VLAN numbers in the range 1005, whereas 802.1q VLAN numbers are in the range of 1 to 4094. The default behavior of VLAN is to permit all normal and extend range VLANs across the link if it's an 802.1q interface, and to permit normal VLANs in the case of an ISL interface. Now let's talk about VLAN trunking protocol. We have a concept of VTP is a protocol that is used to distribute and synchronize information about VLAN database configured throughout a switch network. VTP minimize misconfiguration and configuration inconsistencies that might result in various problems, such as duplicate VLAN names, incorrect VLAN type specification, and security violence. The section that we want to discuss about it is about VTP Modes, VTP Version, VTP Purring, VTP Authentication, Advertisement, Configuration and Verification, also configuration writing. If we want to more specific about VTP, I should say VTP is a layer 2 word protocol that maintains VLAN configuration by managing the additions, deletions, and name changes of VLAN across networks. As I show you in a figure, switches transmit VTP messages only on 802.1q or ISL trunks. Cisco switches transmit a VTP Summary Advertisement over the management VLANs. By default is VLANs 1 as we talk about it, using a layer 3 multicast frame every 5 minutes. VTP packets are sent to the destination MAC address that is I think 0100110C, and the other octet is a CC double C. I try to show you in a figure with a logical link control that is called LLC code of Subnetwork Access Protocol SNAP and AAAA, and a type of 2003 in the snap header. In a figure, configuration made to a single VTP server propagates across trunk links to all connected switches in the network in the following manner. Step 1 is an administrator adds a new VLAN definition. Step 2 is VTP propagates the VLAN information to all switches in the VTP domains. And the end step is each switch synchronize its configuration to incorporate it to the new VLAN's data. VTP domain is one switch or several interconnected switches sharing the same VTP environment, but switch can be only the one VTP domain at any time. By default, a Cisco switch is in the non-management domain state or null until it receives an advertisement for a domain over a link, a trunk link, or until you configure a management domain. Configuration that are made on a single VTP server or propagate across trunk links to all the connected switches in the network. Configuration will be exchanged if VTP domain and VTP password match. VTP is a Cisco protocol. Actually, we don't have a lot of VTP mode. We have three VTP modes that are a client server transparent, and as you see in a figure, if you are a client mode, cannot create, modify or delete VLANs, and you just receive the every changes, buys and deletes VLANs, or every as I said, every changes that you received on a server mode. So if a switches is server mode, can create, modify and delete VLANs. And if we have a server, or if we have a endpoint device, we should use the switches that are in the transparent mode, because we don't want to apply all changes that come from the server. We just have a static configuration, a static VLAN with a static IP address. So if you have a something device that you don't want to changes, you should change the mode of the transparent mode. Now let's talk about the VTP version. Cisco switches support 3 different versions of a VTP, 1, 2 and 3. It's important to decide which version to use, because they are not interoperable. In addition, Cisco recommends running only one VTP version for network stability. We want to talk about VTP version 1 and 2 because VTP version 3 is not the most frequently used version of the VTP. The default VTP version that is enabled on a Cisco switch is version 1. If you do need to change the version of VTP in the domain, the only things that you need to do is to enable its VTP server. The change will propagate throughout the network. VTP version 2 offers the following features that version 1 does not. There are few features. The first one is version dependent transparent mode. In this feature, VTP transparent work device inspect VTP message for the domain names and version, and forwards a message only if the version and domain name match. Because only one domain is supported in the supportive engine software. VTP version 2 forwards VTP message in a transparent mode without checking the version. The second one feature is a consistency check. In VTP version 2, VLAN consistency checks such as VLAN names and value are performed. However, this is only done when you enter information throughout the command line interface (CLI) or a simple network management protocol SNMP. Consistency checks are not performed when new information is obtained from a VTP message or when information is read from NVRAM. If the digits on a received VTP message is correct, its information is accepted without a consistency check. The other feature is token ring support. VTP version 2 supports token rings, LAN, switching, and VLANs. Unrecognized type, length, value, and support is the last feature in version 2, and version 2 switches propagate, receive configuration, change message out other trunk link, even if they are not able to understand the message. Instead of dropping the unrecognized VTP message, version 2 still propagates the information and keeps a copy in NVRAM. And if we want to talk about about version 3 VTP, the version version 3 VTP extend VLAN support, which means VTP also can be used to propagate VLANs with number of 1070 and 4094. The domain name is not automatically learned, which means with the VTP version 2, a factory default switch that receives a VTP message will adapt to the new VTP domain name because it is a very dangerous behavior. VTP version 3 forces a manual configuration. And the other advantage in version 3 is better security. VTP domain password is secure during transmission and in the switch database. We have a better database propagation, which means only the primary server is allowed to update other device, and only one server per VTP domain is allowed to have these rules. Also, multiply a spanning tree that called MST support in VTP version 3. VTP version 3 support for propagate of MST instantly. VTP version 3 is not compatible with version 1 and version 1 because version 3 is compatible just for VTP as long as you are not using it to propagate private or extend VLANs. Now let's talk about VTP Purring. VTP Purring uses VLAN advertisements to determine when a trunk connection is flooding traffic necessarily. By default, a traffic connection carries traffic for all VLANs in the VTP management domain. Commonly, some switches in an enterprise network do not have local ports configured in each VLAN. As you see in the figure, switches 1 and 4 support ports statically configured in the red VLAN. VTP Purring increase available bandwidth by restricting flooded traffic to those trunk links that the traffic must use to access the appropriate network devices. In this picture, we can see a switch network with a VTP Purring enabled. The broadcast traffic from host or workstation is in red VLAN and not forward to switches 3 and 5, also 6. Because traffic for the red VLAN has been pruned on the links indicate on switches 2 and 4. Regardless of whether you use VTP Purring support, switches run an instance of STP for each VLAN. An instance of STP exists for each VLAN even if no ports are active in the VLAN, or if VTP pruning remove the VLANs from an interface. As in result, we can see VTP pruning prevents flooded traffic from propagated to switches that do not have member in a specific VLANs. However, VTP pruning does not eliminate the switch's knowledge of pruning VLANs. And I want to talk about VTP authentication. VTP authentication is VTP domains can be secure by using the VTP password features. It is important to make sure that all the switches in the VTP domain have the same password and domain name. Otherwise, a switch will not become a member of the VTP domain. Cisco switches use the managed digits 5 or that called MD5s that is not secure to encode password in a 16-digit words. This password propagate inside VTP Summary Advertisement, and in VTP password are case sensitive and can be 8 to 64 characters in length. The use of VTP authentication is a recommended practice, and I will show you in a packet tracer. And we have another concept that that names advertisements. In VTP, advertisements are flooded throughout the management domain, which means VTP advertisements are sent every 5 minutes or whenever there is a change in VLAN configuration. Advertisements are transmits with the untagged over the native VLAN. The default VLANs was VLAN 1 for native VLAN. Using a multicast frame, and it sounds slow. A configuration revision number is included in each VTP advertisement. A higher configuration revision indicates that the VLAN information being advertised is more current than the store information. One of the most critical components of VTP is the configuration revision number. Each time a VTP server modifies its VLAN's information, the VTP server increments the configuration revision number by 1. The server then sends out a VTP advertisement with the new configuration revision number. If the configuration revision number being advertised is higher than the number stored on the other switches, in the same VTP domain, the switches overwrite their VLAN configuration with the new information that is being advertised. Let's see a picture. And as you see, when the VLAN was added into the database on the VTP server switches, it increased the revision to 4 and advertise the rest of the domain switches that are in the client or server VTP mode. However, the switch in transparent mode does not change its revision number or its database. We talked about the transparent mode earlier. The configuration revision number in VTP transparent mode is always 0 because a VTP transparent switch does not participate in VTP. The switch does not advertise its VLAN configuration or synchronize its VLAN database open of VTP advertisement. A device that received VTP advertisement must check various parameters before incorporating the received VLAN information. First, the management domain name and password in the advertisement must match those values that are configured on the local switch. If the configuration revision number indicates that the message was created after configuration currently in use, the switch incorporated the advertised VLAN information.